Hi, welcome to my channel. In this episode, we are going to have a 5 minutes intro to thermofluids, a simple overview to get familiar with it. Basically, thermofluids module include 3 branches: thermodynamics, fluid mechanics, and something called heat transfer. But don't worry, we won't dive into heat transfer today. For now, we will just focus on thermodynamics and fluid mechanics. Firstly, thermodynamics. From its name, thermo means heat. Ouch! I wasn't supposed to touch it. Anyway, thermodynamics is all about energy, how it's transferred, transformed, and used. It studies things like heat, work, temperature, and energy conservation. In simpler words, it's equal to, where did the energy go? It helps us understand how engines and pistons work, how fridges and air conditioners cool, or even why your tea gets cold. Let's have a quick compare between temperature and heat. Temperature is the measure of how hot or cold a substance is, while heat is the energy transferred due to temperature difference. Temperature unit is Celsius or Fahrenheit or Kelvin, while heat unit is joules. Temperature doesn't transfer while heat transfer from hotter to colder objects. In another thoughts, it's said that temperature is the measure of the average kinetic energy of the molecules, while heat is the total kinetic energy of the molecules. Therefore, we conclude that fast molecules equal high temperature and slow molecules equal low temperature. Moving forward to fluid mechanics. From its name, fluid means liquid. No. Actually, a fluid is both a liquid and a gas, anything that can flow and doesn't hold a fixed shape. Fluid mechanics studies how fluids move and behave under different conditions. It looks at pressure, flow rate, and how forces act on fluids. We use it to design things like water pipes, airplane wings, or even medical devices that deal with blood flow. Another compare between liquid and gas: liquids' particles are closer than gases, while gases' particles are far apart. Liquids have higher density than that of gases. Liquids have fixed volume, while gases has no fixed volume, which make liquids almost incompressible, while gases are easily compressible. Attention! There is a very important relation between density and compressibility. When the fluid is incompressible, such as in liquids, the density stays constant even under pressure. On the other hand, gases are compressible, so their density changes significantly when pressure or temperature changes. That's why we usually assume constant density in liquid flow problems, but not in gas flow problems. This note is important for problems later on. Both thermodynamics and fluid mechanics have key concepts or parameters they follow, like internal energy, enthalpy, entropy, first and second laws of thermodynamics, or like density, pressure, flow rates, and the King Bernoulli. Sounds like a lot? Chill, we'll break down each of these concepts step by step. You don't need to memorize everything now. We're going to learn it all slowly, clearly, and with real examples that actually make sense. Let's sum up everything we've explored so far, starting with thermofluids definition. Thermofluids is the science that study heat, fluid flow, and their interactions to analyze energy and motion in engineering systems, combining principles from thermodynamics, fluid mechanics, and heat mass transfer. Then thermodynamics is the science that explores relationship between heat and energy in different forms, and how thermal energy is converted. Fluid mechanics, science that deals with behavior of fluids at rest or in motion, and the interaction of fluids with solids or other fluids at the boundary. We have also learned the difference between temperature versus heat, and liquids versus gases, and applications and also parameters for both thermodynamics and fluid mechanics. In the next episodes, we are going to learn about extensive and intensive properties. What are they and difference between them, and also types of systems and how they differ. All of this and more by making engineering funnier and a bit sassy with Mechnificent.